Welcome back. Now if you're wondering why you're staring at a pile of cables here, it's I'm attempting to make aluminium bronze for a bushing that I want to make for a wheel bearing. Now aluminium bronze is very expensive if you go and buy it, but if you've got copper offcuts and bit of aluminium that you can use, you can make your own. It's not rocket science. You need about 5 to 6% of aluminium per weight mixed with copper. And that will give you an alloy that is extremely hard and also hard wearing. So yeah. Now the cables that you're looking at is remnants from my old lead acid batteries that I used to have for my solar system. Now I've recently replaced them with lithium ion batteries, and these things have become redundant. So there's a lot of lead, where I used to have 12 lead acid batteries, I've replaced it with 3 lithium ions. So all this copper is spared. Instead of just scrapping it, I'm going to make good use of it. Now I'm going to strap it with this little tool here. If you can see it, it's got a little blade in there that's adjustable with this knob here at the bottom. So what this does, it cuts it in the length of a cable. Now you just need to get it dialed in perfectly so that it cuts the correct depth and only into the insulation and not into the cable itself. Just clamp it over it, pull it, and it will cut it down the length. Pretty easy. So I'm going to clean up these cables off camera. Some of the terminals and ends of the cables have got acid on them. That's not really a concern because acid will create a flux in a crucible. Right, let me clean this off camera. Okay, it took me half an hour to strip down this copper, and I must say my fingers are quite sore after this exercise. But yeah, it's nice and clean copper. You can see there is some bit of acid residue. That's from the batteries, that won't matter. So yeah, it's, if you don't have copper cable, if you're into electronics like I used to be, all the components, your transistors, the little back plate on which the silicon is attached to is made from copper, so you can use that as a source. All transformers you can use as a source of copper, but just be mindful that if you have microwave transformers, it will look like copper, but almost guaranteed that it will be a copper coated aluminium. So it's best just to cut the ends open and look at the tips. The tip is it's got a silvery color to it, and you know it's aluminium. Right, I'm going to measure it out and see how much copper I've got, and then determine how much aluminium I need to add. Alright, 1.3 kilograms. That means I have to add 70 grams of aluminium to get a ratio just above 6%. Yes, about half this. All these offcuts was right on the money, 70 grams. Just look at that beautiful color. It's almost gold. You see a little bit of copper on the outside. Now what I've done is I've used a toilet roll to in the sand to give me a rough, what's his name, shape to cast this in. If I really wanted to, I could use a pipe and get a better finish and a better, what's his name, but just for a quick job, I think this came out very nice. You can see here's a crack here where the pour was interrupted because it was starting to boil over. I'm going to cut it off there, and then just this piece alone is about 400 bucks. You have to go buy it. See if the bandsaw is going to cut it. Okay, I've knocked 2 holes, marks of the punch to test to see whether this material is brittle. Because if you add too much aluminium to it, then it becomes brittle and it will shatter when you try to punch it. So it's not shattering, so it's a good sign. And yeah, my bandsaw took around an hour and 15 minutes to cut through this piece to give you a perspective as to how wear resistant this material really is. Because if I was cutting a piece of mild steel this size, we would have gone through it in 5 minutes. So for a bearing material that's going to be exposed to sand and water and dust and all kinds of other uglies, I think this will be perfect. Now that is going to wear the shaft, that it's going to run through it, but that I'll also change to this material once I get to that stage. Now currently the wheel in which this thing is going to be fitted is just steel on steel, and that has been worn badly. So I think this will be a nice improvement. This it melts at around 1038 degrees Celsius. So it's not as high as copper itself, because aluminium helps it a little to melt as well. And I really love the color of it. In its state now, it almost looks like brass. On some pieces of it, it will, if you look at it with your naked eye instead of through the camera, it almost has a golden color to it. I'm sure if I machine it and polish it up, the whole thing will have a goldish color to it. Well, I hope you've learned with me how easy it is to make aluminium bronze and what a proper piece of this material is. Until next time, enjoy.